Okay, so we're going to pick up where we left off. We're going to do this last problem with regular division of polynomials. So we've got x minus 2, and we're dividing that into 2x squared plus 3x minus 14. Okay, so we divide x into 2x squared, goes 2x times x is 2x squared. 2x times negative 2 is negative 4x. Subtract 3 minus negative 4x is 7x. Bring down the 14. Divide again. X into 7x goes 7 times. And 7 times x minus 2 is 7x minus 14. So we get no remainder. And remember that when you do long division, so for example, if you have 2 divided into 6, and 2 goes into 6 3 times 2 is 6, subtract, you get no remainder. When you do division, you know that this is the divisor, this is the dividend, and this is the quotient. And the divisor times the quotient is equal to the dividend. Well, the same thing is true here. So x minus 2 times the quotient, 2x plus 7, is equal to the dividend, 2x squared plus 3x minus 14. So using this division, really what we've done is we have factored this polynomial, because now we can see the two factors. And we already knew how to do this, but when we have higher order polynomials, it's not so easy. And so this is where we're going with this. We're going towards factoring higher order polynomials so that we can solve them, because factoring is what we do to solve these kinds of equations using the zero factor theorem. So moving on to synthetic division. Whenever we have a division problem like this is the problem we just did, where we're dividing, our divisor is a binomial where it's just x minus some number, then we can use this different way of doing it, which is much less complex. So these are the steps for using synthetic division. And so we'll just do this example. We'll do the same problem we just did. And so what we do is we're looking at this divisor, x minus 2, and that is our x minus c. And whatever this number is, whatever c is, we're going to put that into a little box. So in this case, our c is 2. And if you get confused about whether it's 2 or negative 2, just remember that whatever this is, we want to choose the value that makes it 0. So 2, if you put 2 in for x, 2 minus 2 is 0. So whatever x will make it 0, that's our c. So we're going to put 2 in this box, and then we're going to write the coefficients of the dividend. So we've got 2x squared, and we're doing this in order of the powers of x. So we've got 2x squared, we're just going to put the coefficient. We've got 3x, we're going to put the coefficient 3, and then we have our negative 14. Then we put a line below it, and we leave a space. First step we do is to bring down this 2 and put it here. Then we multiply 2 times this 2, which is 4, and we put that here. Then we add these two numbers, 3 plus 4, which is 7. And then we start over. 7 times 2, right here, is 14, and we put that here. We add these two numbers, and we get 0. Okay, so what we have here, this is our quotient. It just doesn't have the x's with it. And so we're going to write it as a polynomial where this is going to be the highest coefficient. This is going to be the leading coefficient, and this will be the constant, because the function we started with was a degree 2 function, so our quotient is going to be degree 1. So this translates to 2x plus 7. So just like the one we did before, that was our quotient, and so that is what this represents. Okay, we'll do a couple more examples, and it'll become a little more, you'll feel a little more sure about it. All right, so we're going to divide this by x minus 4, And so our C is whatever will make this 0. That goes into the bracket. So that would be 4. And then we're going to write our coefficients of this function in order from the highest power of x to the lowest. So we've got 2x cubed, that comes first, the 2. We've got negative 10x squared, so the negative 10 comes next. We don't have an x term in this function, so we have to include a 0 for that to take up that spot. And then we have a minus 5 for our constant. Now we are going to put our line, and we're going to start. Bring down the 2 to this area right here. Then multiply. 2 times 4 in the bracket gives us 8, and we put that right there. Now we add. Negative 10 plus 8 is negative 2. Now we multiply. Negative 2 times 4 is negative 8, and we put that right there. Add 0 minus 8 is negative 8. Multiply again. Negative 8 times 4 is negative 32. That goes right here. And we get negative 37. So this answer translates to 2x squared minus 2x minus 8 plus the remainder 37. Okay, so this last number is the remainder. And these numbers are the coefficients of the terms of our quotient, and that's always going to be 1 less. It starts out with an x power 1 less than the power of the dividend. All right, here's another one. We're dividing this time by x plus 2, and the number that makes x plus 2 equal to 0 for x would be negative 2. So negative 2 goes into our bracket. Now we write the coefficients for the powers of x. We've got 1x to the 4th, 4x cubed. We don't have an x squared term, so we have to put a 0. We have negative 2x, so negative 2, and 18. Leave a blank, leave a space, and put your line. Bring down the 1. 1 times negative 2 is negative 2. 4 plus negative 2 is 2. 2 times negative 2 is negative 4. 0 plus negative 4 is negative 4. Negative 4 times negative 2 is 8. Negative 2 plus 8 is 6. 6 times negative 2 is negative 12. And so we get a remainder of 6. So this means that our quotient is going to be 1 less. The x power will be 1 less than the original dividend. So it's going to be x cubed. So 1x cubed plus 2x squared minus 4x plus 6 plus the remainder is 6 over x plus 2. Okay, now we have gotten to the remainder theorem. The remainder theorem says that if a polynomial f of x is divided by x minus c, then the remainder is f of c. In other words, the value of f of c is the same as the remainder we get from dividing f of x by x minus c. And the reason for this is if you're dividing a function, f of x, by x minus c, you're going to get a quotient and a remainder. We know that the dividend is equal to the divisor times the quotient plus the remainder. F of x equals the divisor times the quotient plus whatever the remainder is. So if this is equal to this, then f of c is equal to c minus c times the quotient plus the remainder. And so since c minus c is 0, we can see that f of c is equal to the remainder whenever you do this kind of division. It's helpful to know this, and we're going to just kind of practice knowing it, and we'll find out what it's useful for. So given this function here, we're going to use the remainder theorem to evaluate f of 2. All right? We could evaluate f of 2 quite easily by putting 2 into the function, which is what we've always done. But we're going to use the remainder theorem instead. And what the remainder theorem tells us is that if we divide this function by x minus 2, then the remainder we get is going to equal f of 2. F of 2 will be the remainder we get if we divide this function by x minus 2. And the way we do that is using synthetic division. So we'll put our 2 in the bracket. We'll put our coefficients 1, 6, negative 12, negative 30, and 35. And then we will put a line, bring down the 1, multiply, get 2, add it up, get 8. 8 times 2 is 16. 16 and negative 12 is 4. 4 times 2 is 8. Negative 30 plus 8 is negative 22. Negative 22 times 2 is negative 44. And we add that up and we get negative 9. Okay, so f of 2, therefore, is negative 9. That's what the remainder theorem tells us. Whatever the remainder is when you divide by x minus 2 is f of 2. And you can check that by just putting 2 into this function. So if I put 2 into this function, I'll get 2 to the 4th plus 6 times 2 cubed minus 12 times 2 squared minus 30 times 2 plus 35, which gives me 16 plus 48 minus 48 minus 60 plus 35, which if you add it up does equal negative 9. So this is what the remainder theorem tells us. All right, we'll use the remainder theorem again over here to find f of negative 7. In other words, we are going to divide this function by x plus 7 and see what the remainder is, and whatever that remainder is f of negative 7. So in our bracket, we're going to put the negative 7. We're going to put the coefficients again, 1, 6, negative 12, negative 30, and 35. Put our line, bring down the 1. 1 times negative 7 is negative 7. Add it up, you get negative 1. Negative 1 times negative 7 is 7. Add it up, negative 5. Negative 5 times negative 7 is 35. Add it up, you get 5. 5 times negative 7 is negative 35. So the remainder is 0. So f of negative 7 is 0, which means that negative 7 is a 0 of this function, which means that it is where this function would cross the x-axis. One of the places where it would cross the x-axis would be at x equals negative 7. And it also tells us that x plus 7 is a factor of this function. All right, we're going to use the remainder theorem to determine if the given number c is a 0 of the polynomial. So just like the one we just did, we're trying to find out if we can get a remainder of 0. And if we get a remainder of 0, that would tell us that whatever this number is that we're using for c is a 0 of the given polynomial. So for part A, we're going to take 4, and we're going to use synthetic division on this polynomial, 2x cubed. So 2x cubed minus 4x squared minus 13x minus 9. See if this gives us a remainder of 0. Bring down the 2, multiply. 2 times 4 is 8. Negative 4 and 8 is 4. 4 times 4 is 16. We get 3. 3 times 4 is 12. So we get 3. No, not a 0. Because the remainder is not 0. So f of 4 is not 0. Part B, we're going to try and see if square root of 3 is a 0 of this function. So square root of 3, put the bracket. We've got 1x cubed, 1x squared, negative 3x, and negative 3. So we're going to bring down that 1, multiply. 1 times square root of 3 is square root of 3. We have square root of 3 plus 1. Multiply square root of 3 plus 1 times 3, and you get 3 plus the square root of 3. Add it up, you get the square root of 3. Square root of 3 times square root of 3 is 3. Add it up, you get 0. So yes, this is a 0 of the function because the remainder is 0, which means that f of the square root of 3 is 0. That's the remainder theorem. All right, one last one. We've got C. We're trying to find out if 1 plus 2i is a 0 of this function. So we're going to divide 1 plus 2i. And we've got 1x cubed. There's no x squared in that function, so we'll put a 0 for that. We've got 1x and 10. All right, bring down the 1. 1 times 1 plus 2i is just 1 plus 2i. And that added up is just 1 plus 2i. Now we need to multiply 1 plus 2i times 1 plus 2i. I'm just going to do it over here. So that's going to be 1 plus 2i plus 2i plus 4i squared. So that is 1 plus 4i minus 4. So that's going to be negative 3 plus 4i right here. And then when we add 1 plus that, we're going to get negative 2 plus 4i. And now we're going to multiply negative 2 plus 4i times 1 plus 2i. And when we do that, we're going to get negative 2 minus 4i plus 4i plus 8i squared, which is going to be negative 2 minus 8, so negative 10. And we do get 0 for our remainder. So yes, 1 plus 2i is a 0 of that function. This will move us on to another theorem, which says that let f of x be a polynomial. If f of c equals 0, then x minus c is a factor of f of x. If x minus c is a factor of f of x, then f of c is going to be 0. So if you had a polynomial that had these factors, and it doesn't really matter what these factors are, just say there's more factors, well, f of c is going to make that equal to 0. So if x minus c is a factor of a certain polynomial, that means that f of c is equal to 0, because if x minus c is a factor, if you put c in for x, you get 0 for that factor, which multiplied by everything else makes 0. We've already been learning that with solving quadratic. So if we had something like x squared minus 3x plus 2, and we factor that, it would be x minus 2, x minus 1, then we know that 2 and 1 would be solutions to this equation. So 2 and 1 are zeros of that polynomial. So f of 2 would be 0, f of 1 would be 0. And that tells us that x minus 2 and x minus 1 are factors. And if x minus 2 and x minus 1 are factors, we know that f of 2 and f of 1 are zeros. So that's all that this factor theorem is telling us. So we're going to use the factor theorem to determine if the given polynomials are factors of this function. All right, so for x minus 3 to be a factor of f of x, that would mean that 3 is a 0. In other words, we need to check and see, is f of 3 0? And to do that, we'll use synthetic division and see if we get the remainder of 0. So we're putting 3 in our bracket, remember, because whatever makes the factor 0 is your c. And we're going to put the coefficients on this function f of x. So 1, negative 1, negative 11, 11, and 12. We do the division, bring down the 1. 1 times 3 is 3. Add it up, you get 2. 2 times 3 is 6. Negative 5. Negative 5 times 3 is negative 15. Add it up, you get negative 4. Negative 4 times 3 is negative 12. So you do get 0, and therefore, yes, x minus 3 is a factor of this polynomial by the factor theorem. X plus 2, let's see if that is a factor. To check if that's a factor, we have to see if f of negative 2 is a 0. Okay, remember you have to choose the number that makes this equal to 0. So we're checking to see, is f of negative 2 0? If it is, then x minus negative 2 is a factor. In other words, x plus 2 is a factor. So we're going to check it out. Put negative 2 in the bracket, put the coefficients 1, negative 11, 11, and 12. do the synthetic division, bring down the 1. 1 times negative 2 is negative 2, add it up. Negative 2 times negative 3 is 6, negative 5. Negative 5 times negative 2 is 10, 21. And 21 times negative 2 is negative 42, so no, that's not 0. That is negative 30, so no, x plus 2 is not a factor of this polynomial. All right, so now we're going to start seeing what this is useful for. I have this polynomial, 3x cubed plus 25x squared plus 42x minus 40. And I want to find solutions for it, let's say, for this equation. Sorry, that's supposed to be 0. 3x cubed plus 25x squared plus 42x minus 40 equals 0. Say I want to find solutions to that equation. Well, to find solutions, I need to factor it. But what if I don't know how to factor it? Maybe it's not very easy to factor, which it's not. So thankfully, they have told me that one piece of information, that negative 5 is a 0 of this function. If negative 5 is a 0 of this function, that means that x minus negative 5 is a factor by the factor theorem. Therefore, when I divide this function by x minus negative 5 or x plus 5, whatever's left over is going to be the other factor that will go with this. So I will get it partially factored if I go ahead and do that division by x minus negative 5. So I'm going to do it. Put the negative 5 in the bracket. I've got 3x cubed, 25x squared, 42x, and negative 40. Bring down the 3. 3 times negative 5 is negative 15. I've got 10. 10 times negative 5 is negative 50. 42 minus 50 is negative 8. Negative 8 times negative 5 is 40, and that's 0. So we already knew that was going to be 0 because they told us negative 5 is a 0 of the function, which means x plus 5 is a factor. So what do we have here? Well, we divided by x plus 5. And what do we have left? We have 3x squared plus 10x minus 8. So this is partially factored now. This is what I started with. This factors to be this because I divided by x plus 5 and this was my quotient. So divisor times quotient equals dividend. All right. Now I can complete this factoring process because I know how to factor a quadratic. I can either factor it just by factoring or I can use the quadratic formula. So I'm going to factor it. The x plus 5 is right there. Then I'm going to have 2 sets of parentheses here to factor the 3x squared plus 10x minus 8. So that would be 3x and x, and we could use 2 times 4. So if I put a 4 here and a 2 here, and I make this positive and this negative, that will give me 3x squared plus 10x minus 8. So I have completely factored f of x now, this function we started with. And just being given this 1, 0 helped me to find one factor so that then I could divide that factor out and see what's left and then factor whatever was left. So now part B says solve the equation that function equals 0. So I want to solve the equation x plus 5 times 3x minus 2 times x plus 4 equals 0 because these three factors multiply together to give me f of x, and that's what I want to set equal to 0 and solve. So since it's already factored, I know that the solution set x would be negative 5, or x could be 2/3, or x could be negative 4. So these three values are the solution set to that equation, setting the function f of x equal to 0. And so I've solved that cubic equation. So this is what all this is about. It's about solving these higher order equations, finding a 0 in some way that you can, and then using that to factor at least one factor out of the equation of the function so that you can then maybe factor whatever's left. All right. Now, example 10 wants us to write a polynomial f of x of degree 3 that has the zeros 1/2, square root of 6, and negative square root of 6. So we're going to use the factor theorem that tells us if f of c is equal to 0, then x minus c is a factor. All right, so I know all these numbers right here are zeros. So f of 1/2 is 0. F of the square root of 6 is 0. F of negative square root of 6 is 0. And that tells me that the factors for this polynomial are x minus 1/2, x minus the square root of 6, and x minus negative the square root of 6. If f of c is 0, then x minus c is a factor. All right, so now I can multiply this all out to have a polynomial f of x of degree 3 that has these zeros. And I mean, it already is f of x, but if I want it to look nice, I need to go ahead and multiply it out. All right, so that's x minus 1/2, and this is x minus the square root of 6 times x plus the square root of 6. And I know that when I multiply conjugates, I get a difference of squares. So I can do that first. This is going to be x squared minus the square root of 6 squared. So I've got x minus 1/2 times x squared minus 6. And now if I multiply that out, I'll have x cubed minus 6x minus 1/2 x squared plus 3. So that is f of x. That is a cubic function that has those 3 zeros.